All right, so the first section that we did was chain rule related to polynomials. Now we're going to do chain rule related to like trig and logarithms and exponentials. And then the one thing we haven't really talked a whole lot about was inverse trig. So all of these arc sine, which is sine to the negative first power, first power, or tangent to the negative first power. So those are inverse trigs. So tangent inverse, sine inverse is the same thing as saying arc sine or arc cosine or arc tangent. And so you have all those. Here's all your exponential derivatives as well. So now we're going to start these. So y prime is the derivative of sine, which is cosine of 2x. And then multiply by the derivative of the inside, which is just 2, not 2x. I notice I put an extra set of parentheses around here. So that would have given me y prime is equal to 2 times cosine of 2x, which I didn't need the parentheses, really. So I could have done it as y prime is equal to 2 cosine 2x like that. Okay? So now let's look at another example. So here's the weird thing about trig is that I'm supposed to really write this as tangent of x, the quantity squared. So when I look at my derivative, right, that should be 2 tangent of x to the first power multiplied by the derivative of tangent, which is secant squared of x. And then I don't need this little first power guy if I don't want to. So it could have been y prime is equal to 2 tangent x secant squared x. All right, so now y prime negative sine is the derivative of cosine. And then the derivative of my 4x minus 1 is just 4. So y prime is negative 4 sine of 4x minus 1. Arc cotangent, so that is back way over here. Arc cotangent's derivative is negative 1 over 1 plus x squared. So this would have been y prime negative 1 over 1 plus something squared, which is the root of 2x plus 3. So I worked my way from my outside. Now I got to do my derivative of my inside, which my first inside is a square root of x. So that means 1/2 2x plus 3, to the negative 1/2 power. That deals with everything except for now I had to deal with the derivative of 2x plus 3, which is just 2. And now lots of things cancel out. The 2's cancel out. So now I'm left with y prime is negative 1 plus 2x plus 3, because that's squared and that square root cancel each other out. And then I'm left with also a root of 2x plus 3 in the denominator because of that negative exponent. So now y prime is equal to negative 1 over 2x plus 4. And then I have a root 2x plus 3, which more than likely they would have done this on algebra. Negative 1 over 2 times x plus 2 and root of 2x plus 3. Okay? So now, let's look at another example. Arc sine. So arc sine's derivative is 1 over root 1 minus x squared. So y prime is 1 over the square root of 1 minus my x squared. This 1 over x is x to the negative first power, so this is negative x to the negative second power. So I get negative 1. I have an x squared down here, and my root is 1 minus 1 over x squared. So negative 1 x squared minus 1 over x squared. So now I have negative 1 x squared root x squared minus 1 over x. One of those x's cancel out, and I'm left with negative 1 x root x squared minus 1. Kind of crazy. I know it's weird. It's just weird because of this whole, like, negative first power, because then I ended up with a complex fraction there. Okay, so y prime, derivative of the outside is e to the x squared, and then multiplied by the derivative of x squared, which is just 2x. So y prime is 2x e to the x squared. My logarithm derivatives, wow, there's a lot of examples today. So y prime is 1 over x, which is my x squared, ln of 4, multiplied by the derivative of x squared, which is 2x. So one of my x's cancel out. So I'm left with y prime is 2 over x ln of 4. All right, and then this is really x to the negative third power. So y prime is 1 over x to the negative third times, negative 3x to the negative second power. So this is really 1 over x cubed. So then my y prime ends up being x cubed in the top, a negative 3 in the top, and an x squared in the bottom. So then y prime is negative 3x. Notice what I did. So this became 1 over x cubed. This turns into the denominator, goes 1 over x squared. The 3 stays in the top. Okay. All right, and then y prime is 3 cotangent of x ln of 3, and then multiply by the derivative of cotangent, which is negative cosecant squared of x. So y prime is negative ln 3 cosecant squared x, 3 to the cotangent x. Okay. And then I have a little, like, picture here, and that is it for this lesson.